Thank you. Okay, so coming to ARM Development Studio. So before coming to ARM Development Studio and before coming to the ARM software solutions offered by ARM, so first let's discuss or throw a light on why anyone should go for ARM development solutions. There are many compiler vendors available in the market for embedded processors, even if you consider ARM processors. What is that which makes ARM unique? What is that ARM offers which makes their solutions unique and which should attract customers to go with the solution? So why ARM development solutions is, in the ARM team, there is a development solution groups, DSG, we call it as. This group mainly work towards targeting the needs of the developers. They always take feedback from the market on how the customers or users are facing difficulties in developing the product or developing the software for the ARM processor. Where are the bottlenecks is? Sorry for that. So where the bottlenecks is, where the users or customers are facing the difficulties. So they always address the needs of the developers. They always address the bottlenecks the customers are facing in developing the software. So first thing is they enable you to develop a secure, energy efficient software which works on your hardware. And when the ARM releases the new processor code to the market, so even before the silicon vendors comes with a processor based on that particular IP core, ARM compiler will give support for that particular processor. So that means what? What is the advantage there? That means even before you have your any silicon vendor processor you're working, even before that you can develop your software for that particular core and keep your code ready, or you can get your product to the market on time even before the silicon is available. We'll be discussing more on these points in the coming slides and help developers improving their performance and create products. Improving the performance is ARM strategy. Hope the team everywhere in the attendees knows that ARM does not manufacture silicon of its own. So ARM only licenses their IP core. The semiconductor vendors approach ARM and they license this IP core, and they to put this particular core, they may put peripherals or whatever they're required per blocks, and they bring it to the market as a processor or a microcontroller based on what processor core it is. Okay, so but ARM has developed the compiler themselves for their processors. So because they themselves have designed the IP code, so they know how well they can get the optimized code out of that particular processor core. So they have taken care of everything which is required to get the most optimized code in optimal way from any ARM processor. So that ARM compiler is provided as part of this ARM software solutions. They also offer development tools that shortens time to market and lower cost. I would like to take this point in the coming few slides because it will be a kind of repetition for you. So, and they have a very strong ecosystem. Ecosystem means for ARM processor, they have a very strong ecosystem. It can be from the software, it can be from the hardware, it can be from the middleware, it can be from the IP, it can be anything. It can be from the IoT, anything. So they have a very strong ecosystem there. So one thing you can see in this slide, 92%. SIP is silicon partners. So out of 25 semiconductor vendors. So semiconductor vendor, I can use it as short form as semicon, or I can use as SIP also. SIP is silicon partner. Out of 25, at least 22 customers, SIPs use this ARM software solutions for their application. So what are the development solutions group offers? which delivers or caters to the customer needs are. They give the technologies, markets, and ecosystem. What sort of technologies they give and what way it is going to help the users. Code generation. The technologies is first it gives you the ARM compiler, which helps you generate the most optimized code and thereby uh, getting a good code performance. Next, you have debug and analysis tool. Debug analysis means this is always required because when you're developing a code in real time and you download the code to the hardware and you see that the code is not working. So there should be some mechanism to get a view into your processor or onto your hardware and to see what's happening, why my code is not working. So that is where the debug analysis tools comes into picture. Simulation models. Simulation models is something where even before your hardware is ready, we can test our code, whatever you have developed on the simulation platform. So hope the team is aware simulation is nothing but the virtual target. Next comes the IP configuration. IP configuration is, this is basically for if the user wants to develop an SOC system on chip or a kind of application specific integrated circuit, which is ASIC, we call it as, or it can be ASSP, it can be anything. So this particular technology is for IP configuration comes there. Next come to markets. So where are these technologies be used? Am I audible clearly? Hello? Let me check the chat. Okay, I'm audible? Yeah, thank you. Yeah, sorry for the inconvenience. Maybe it may be due to the fluctuations in the net speed. Sorry for it. Apologize for it. So please, like I saw someone raise the hand. If you have any issues, please, Sukhvinder Singh, I guess. Please raise your hand so that I can stop there. Otherwise, I'll presume that the team is able to hear me and I can proceed. Thanks. Yeah. Okay. So let me come back to this slide. So basically, ARM Development Solutions Group, they offer technologies which helps you in generating the optimized code and thereby generating the most a good code performance on your hardware. Debug analysis tools in your real-time application when you have written your code and you download the hardware and it doesn't work. So there should be some way to get a peek into your hardware or to the processor, how, why, what's is going wrong, to find out. It can be any hardware issue or it can be software issue. It can be due to memory corruption or a stack corruption. It can be anything. So with the help of debugger, we can easily find out these software bugs. So it is called as debug. Remove the bugs in your software. Next comes simulation models. Simulation models is basically when you don't have your hardware ready. When you don't have your hardware ready, you can test your program on the simulator platform. So if the team is aware that simulation is nothing but the virtual target. Okay, so these technologies to what markets they cater to. It's just written to few here, but ARM solutions, ARM software solutions can be used in Voice is breaking. Is my voice clear now? Harsha, am I audible? Yeah, thank you. So, yeah. So these markets here, it is shown as the software solutions can be used for SOC design. It can be used for embedded and automotive. It can be used for mobile and graphics. It can be service and high performance computing. Embedded and automotive means embedded can be anything here. It can be automotive, it can be railways, it can be medical, it can be industrial, it can be IoT, it can be any. So ARM software solutions can be used for any embedded project. From any lower end to higher end embedded projects, ARM software solutions can be easily used. Okay, coming to ecosystem, you have your GNU compiler. GNU compiler, everyone knows it's an open source compiler, but still it's a part of ecosystem. LLVM is low-level virtual machine technology. The ARM compiler 6 comes under this umbrella. Then we have CMSIS. CMSIS is actually, I'm not sure whether the team here is aware. It is Cortex microcontroller software interface standard. So this is specifically for, it was for Cortex M-based MCUs, and now it is to extended to even Cortex A as well. So this standard was brought in joint collaboration with ARM, Silicon Partners, SIPs, and development tool vendors. Then KEMU. KEMU is actually, they have listed only few, but there are many as a part of ecosystem. If you visit arm.com, you'll get a lot of information on the ecosystem, strong ecosystem, what ARM carries. KEMU is actually a simulation platform from Mentor Graphics. So ARM has been continuously investing in generating a more efficient tools which targets to the customer needs. So this is just a slide I just wanted to show how ARM is growing. I think everyone knows ARM carries itself with the brand, ARM branding. So 1987, ARM launches this compiler. ARM was born from Econ Computers, 1990. It acquires Neural, it acquires Kyle. Kyle was an earlier independent entity. It was a German-based company. ARM is a UK-based company, means UK headquartered in UK. Kyle is headquartered in Germany. So ARM acquired Kyle because Kyle was giving very good software solutions. It was a development tools kind of for 8-bit, 16-bit processor range. So they acquired Kyle. Then 2008, ARM launches CMSIS. Okay, and 2016 is Alinea Studio, this is for mobile applications, and 2018 was where ARM Development Studio was launched. So we are talking about ARM Development Studio in these slides. So this is for tools for SOC design. SOC means everything, all the entire systems go to a specific single chip itself. So when designing an SOC takes a lot of time and effort because many of the blocks, many of the components has to go into a single chip. So what is that ARM offers as a solutions for SOC design here? So first thing we have is earliest IP support, which I already covered in the first slide. So even before Silicon Partner releases a processor to the market, ARM compiler supports that processor, and you can develop the code and test it in the simulation model and get your product ready. And you have golden reference model. So we have very good simulation models offered by ARM. It can be in the cycle, it can be accurate to this cycles, the number of processor cycles. Please mute yourself. Thank you. So golden reference models is, here ARM has given very good simulation models. This will help you to select your IP. Because in a system on chip, main thing is first the main processor core. So which particular processor core you have to use for your SOC. You can do that with the selection of IP. And how do you, IP is your ARM processor basically. Then how do you ensure that this is the right processor for your SOC? With the help of cycle accurate model. So we have cycle accurate models where we can test your program on those models, which gives you the cycle accurate efficiency. Means as if it gives you the correct cycle information as if you're executing the code on the actual hardware. Okay. So even before your hardware is ready, you can select the right IP core for your SOC design. And you have a good support from the ARM team round the clock. So next, enabling faster innovation with shorter product cycles. First slide, I was talking about reducing the time to getting the product to the market, short the product life cycle. So I told I'll park this particular point for next few slides. So I'll talk about that in this slide. So here, with the help of ARM software solutions, you can shorten the product cycle. What does that mean? Usually how the embedded project happens, traditional way. First, you will develop the hardware and the software team or a firmware team will wait until the hardware is ready. So that time is gone and software team is sitting idle there. And once the hardware is ready, your firmware team will start developing the code. So there you have the time to develop your product and getting the product to the market is more. Means it takes more time getting the product to the market. So what does ARM software solution does is, ARM software solutions give you simulation models. We call it as fast models, it can be simulation models, anything. So if you see here, hardware design test line, first the system definition. So first you define a system, what is it, includes what is the particular system is supposed to do and all. Then you select an IP. We're talking about SOC here. This can also be applicable for your normal embedded hardware board also. So then we'll select a specific IP by using the cycle models. This is again simulation. Then this IP configuration and system assembly, this is all in the SOC, how you're connecting the components and all. This is on RTL level. Then generation of the test bench and verification and further implementation of the hardware. So as soon as this IP configuration and system, as soon as the IP selection is done and the IP configuration is done, your firmware team will come into picture here. So this is basically hardware and software co-design happens, means together it happens in parallel. Okay, so here we are developing the software with the help of using the ARM Development Studio to develop your code, compile the code, and finally test the code on the ARM fast models. And then finally we'll test, once the hardware is ready, the firmware can be tested on the hardware. This on silicon test, which is with ARM Development Studio again. So what does this particular slide I want to convey is reduce the product life cycles. What way that is going to benefit to you? Embedded market is a very competitive market, and one customer is working to develop a product. It may not be that it should be a patented product. I mean, any other customer can develop a same product, maybe with the similar features or with the better features. So the customer who releases the product to the market on time will grab the market, will capture the market. So it's basically the main caption code here is time to market. So as how early you release the product to the market, I mean that much you'll be able to capture the market. So ARM software solutions will help you to get your product to the market well before the stipulated time, because here hardware and software code design can happen in parallel because of the very powerful simulation models offered by ARM. Okay, for any embedded project, even if you leave the ARM processor, it can be for any embedded project, time to market is always critical. Okay, because customers develop the product for their client or to whoever it is. So before they have to get the product on time, otherwise the product may not become popular or maybe whatever the reason. So but always get the product on time. This is the caption for ARM software tools. So that is why they have given the simulation models. Okay, so now any questions on a specific slide? So please put it on the chat window. So the same as an extension of the previous slide here. So here the same thing, pre-silicon software development. Pre-silicon software development, pre-silicon means here we are talking about SOC. SOC is a silicon. SOC is a chip, right? So it's a silicon die, silicon chip. So even before your SOC is developed, just how to develop your software. This is what this particular slide shows. So here architecture exploration, this is all your hardware part. In software, also firmware development happens in parallel with your hardware. So it's the same thing, similarly as to the previous slide. It's basically even before your SOC is ready, you'll keep your firmware ready, which will run on your SOC with the help of this simulation models. So again here for early release of working product to lead the customers. So it's basically, as I told previous slide also, getting the product to the market on time to market. Okay. Next is SOC bring up and firmware development. So now you have tested the code on the simulation model. So now when the hardware is ready, when your SOC is ready, now you have to test your code on the actual hardware. So for firmware development, we use ARM Development Studio, which is a key-space IDE. I'll talk about the IDE when I come to the practical demonstration. So with the help of ARM Development Studio, we'll develop your product code, whatever software code, and you test it on your hardware. How do you test it on your hardware? In how to get that particular SOC up in the sense, whatever code you have written, how to get it making work faster on your SOCs with the help of a DStream debugger. DStream is a JTAG debugger. And this JTAG debugger supports all ARM processors from the lower end to higher end. It supports big little combination. It supports multi-cluster. We have SMP, symmetrical multiprocessing, asymmetrical multiprocessing. So your hardware can have heterogeneous processor, or it can be of a similar processor core, or it can be a combination of Cortex-A, Cortex-M, or Cortex-R and Cortex-M. So all such combinations will be supported by this DStream SD debugger. Along with that, if your hardware you are loading, you are porting any OS like Linux or Android, then you can also profile those applications, and you can also do that RTOS aware and Linux aware debugging. What I mean by Linux aware debugging, with the help of DStream, you can also debug your Linux kernel. You are developing your Linux kernel drivers or something, you want to debug it, you can debug with the DStream. Okay. So now this particular slide is to summarize what are the products for your SOC design. Cycle models are basically for selection of your IP and to validate your IP, how well it suits for your application. ARM sockets is basically, this is to the FPGA level or to the SOC level, RTL level, which we are not talking about. ARM fast models is a simulation models which will give you programmer's view for early software development. Next is ARM Development Studio. It's a complete toolset. It's a universal toolset for development of your software on a new SOCs. Okay, so now comes tools for embedded projects. So here we'll actually talk about ARM software solutions. In the previous slides, we talked about software solutions offered by ARM for SOC design. So in this slides, we'll be talking about the ARM software solutions for embedded projects. Though you may tell SOC also embedded, true. But SOC means entire system goes to a chip. Here, embedded is you're developing your hardware with lot of processors, blocks, peripherals, connectivity, lot of complex connectivity, everything it is for that. So the ARM software solutions for embedded projects, what they offer is good in efficiency. It targets the safety and security. And this can be used from sensors to autonomous vehicles. It's just written autonomous vehicles, but it can be used for sensors to any higher end data center or high performance computing. It can be used for anything. All around performance. So ARM software solutions, as I told, they come with ARM compiler. So ARM compiler is a best in class compiler which helps you in generating the most optimized code where the code for executes faster, which occupies less memory on your hardware. Optimized code is finally, it's the code size which is generated by the compiler. Next, safety meets security. What does safety meet security? ARM compiler actually comes with two versions, compiler 5 and compiler 6. Some of these versions are certified for safety critical. Or I should tell in other words, they're certified for functional safety. So what is this functional safety? ARM compiler is TUV SUT certified for developing the applications for safety critical applications, specifically for medical, automotive, railway, and industrial automation. So these are ARM compiler is tested for highest SIL safety integrity levels. So thereby, this will help you to get your product certified. If you develop your product with a safety certified compiler, then you can get your product certified faster and get your product to market on time. Wide ecosystem. So ARM compiler supports, because it's ARM compiler, they support all the processes which are released by ARM from lower end to higher end. So now we'll see what are those ARM products. We talk about ARM software solutions, though these are also part of them only. So we'll talk about ARM products. ARM products series, we have ARM Kyle and ARM Development Studio. So ARM Kyle basically is for single or dual core Cortex-M devices. It is not just only Cortex-M, it is also for even ARM7, ARM9 based MCUs. So ARM Kyle is basically this for MDK, Microcontroller Development Kit. We will talk about that in next slide. So Microcontroller Development Kit, in the sense this particular kit is not a hardware, it's a bundle of software components, and this can be used to develop the software code for any ARM based MCUs, microcontroller units. Okay, but MDK is more suitable for Cortex-M. That's what it means. Then ARM-DS. ARM-DS is a single universal tool suite which is based on Eclipse IDE. If the team is new to word DS, earlier if someone has worked on ARM compiler, it was DS5. Earlier they start with ReLU compiler tools, which is Eclipse based. After that it came it as RVDS, ReLU Developer Suite, which was again Eclipse based. Then RVDS was replaced by DS5 Development Solution, Development Studio 5, and that was replaced with Development Studio, which is DS now. From all the IDEs, softwares, it is still the Eclipse based IDE only. Same ARM compiler. So whatever ARM compiler comes with Kyle, MDK, same ARM compiler comes with ARM DS as well. Okay. So here is non-intrusive ARM core site trace debugger, code editor, project manager. This you see is a part of both the IDEs, both Kyle Microvision IDE and the ARM DS IDE. So here they are showing U-Link Plus. We have U-Link JTAG debugger series. Hope the team might have used at least a U-Link 2 at least. This stream is a JTAG debugger for higher end processor series. Your 32-bit processor core and 64-bit processor core. So this is the MDK development system which I was talking about. This is specifically for ARM-based MCUs, which is Cortex-M. ARM7, ARM9, and Cortex-M based MCUs. So what does this this particular MDK stands for? Microcontroller Development Kit, as I told, and kit is a bundle of software components. What are those software components you get? It is, we have MDK. MDK is MDK core. MDK core is because this Kyle MDK is available for download from the Kyle site, and whenever you download, you get this MDK core, which comes with the IDE, debugger, and the pack installer. Pack installer is basically, with the help of pack installer, the required software pack can be installed inside the Kyle IDE. Kyle IDE is a Microvision IDE. Then we have ARM C or C++ compiler with qualification kit. So this qualification kit is, as I told, ARM compiler is safety certified. So this qualification kit will guide the user to know what are the procedure ARM followed to get their product tool certified. And suppose if the user intends to develop this ARM compiler for some automotive application, then as per the ISO 26262 standard, they want to get their product certified. Then they'll have a qualification kit to find out if at all ARM has taken any deviations from that ISO 26262 standards. Then you can see those information in the qualification kit. Though the qualification kit is available in the higher end of Kyle MDK versions, which is not the topic here because we were also talking about ARM DS. Then we have software packs. This is called as DFP, Device Family Pack. So Device Family Pack, in the sense, as the name suggests, it supports the files associated for developing a code or a firmware for that particular device. Device is a microcontroller, ARM microcontroller. Then CMSIS. CMSIS, as I told, it was a standard, and as a part of standard, ARM has to give some files as a silicon partner. SIPs will give some certain files. So CMSIS gives you some files for those particular processor cores. We have CMSIS cores, CMSIS DSP, CMSIS SORTOS. Like that, we have many flavors of CMSIS. If you visit on arm.com, www.onarm.com, you'll get all the CMSIS flavors or variants, or you can also visit arm.com or developerarm.com. You will get all the information on the CMSIS. Next comes MDK middleware. So what is middleware? So middleware is basically if the user is trying to use some higher end MCU, which has the higher end communication peripherals like higher end MCU, in the sense if they're planning to use any MCUs based on Cortex M3 onwards, M3, M4, M7, M23, M33, M35P, like that, then usually these MCUs have the higher end communication peripherals like USB, Ethernet, CAN, for all those. So if at all the user wants to use those peripherals in their application, then ARM gives you middleware stacks. We call it as middleware library. Is in the library format. No source code is provided. But if you want to get your product certified, a library is not enough and source code is required. Then we do give you because source code is the IP from ARM, because they have developed that. So that is also available on chargeable basis, add-on option. So they give the middleware library for Ethernet, IPv4 and IPv6. We have graphics. You are using any display, you are trying any display in your hardware. Then also this for graphics, they are collaborated with Segger, which is again German-based company. They offer their MWin library, embedded Windows. It's actually called as. So they collaborate with Segger, and the graphics library is offered by MWin. Then we have USB host or device, embed TLS, SSL TLS security. So what does this mean? If this is specifically useful, why at all ARM came up with this is for IoT applications or wherever security is required, if you see that there is a threat for your data being hacked, that time this embed TLS, what it does is it tries to encode whatever data it sends in the packet. It will try to encrypt that data in the TLS level. 7 layers of OSI model. TLS is a transport or the session level. This is a level where the packets form actually. Whatever data, Ethernet data, network data you send, the data is sent in the packets. Hope the team is aware. So this packet formation happens in that particular layer, and here the encryption of the data happens so that transmission between any two devices, data will not get corrupted nor it get hacked. This is for that. File system is if you want to create a file system like you see in your system, C drive, D drive, file folder system, we can create that in flash or RAM, whatever. IoT connectors. What is this IoT connectors is if you are developing an IoT application and you have an device, any device which sends the data to the cloud is called an edge device. So connecting this edge device to the cloud is what this IoT connectors does. Then we have JTAG probes for code coverage. We have ULink Pro. We have ULink Plus for power optimization, and ULink 2. These are all the various variants of ULink debugger. So this particular slide will give you all the features of ARM-Kyle in a single slide. First, here this IDE is easy to learn and use. It's very fast and the IDE is very user friendly and you can easily learn about the IDE. You have an extensive learning material. You get it from when you install the software, you'll get that, or you can get it from the Kyle site. And this IDE can be integrated with Jenkins for any continuous integration. Memory analysis, this is all part of your debugger. So if you come to here, debugger part, this is system analyzer. Here you can see all the information. It shows the core clock, it's a power consumption, any variables used in your program, any exceptions, interrupts in your application which the processor has gone through, and auto-setted information. Everything you get it in a single window, system analyzer. So it offers feature-rich debugger. Okay, and debug connection, we use any of the JTAG debuggers which I showed in previous slide. Energy measurement is done through PuLink Plus. Then timing analysis is based on the instruction trace. So if the processor is capable of generating the instruction trace, how it generates, if the processor has ETM block. When I take processor, it's an MCU, microcontroller unit. If it has embedded trace macro cell block, and if you're using a JTAG debugger which has the intelligence of reading that ETM trace, instruction trace, then you can connect that to Kyle IDE and capture that trace. With the help of that real-time trace, Kyle IDE can also give you the code profiling. Code profiling is basically to profiling your code, which parts of the code has been executed, what all functions have been executed. In those functions, what are the lines which was skipped. Usually the lines which have the conditional statements for, if, else, while is what is usually gets skipped. And then we have execution statics. Execution statics is we also have performance analysis. Performance analysis is to find out the hotspots in your application, where the processor is spending maximum time. So thereby you can try to optimize that particular part of the code. And it also gives you the time taken by for the execution of each every C statement, or if it is an assembly also, you can see that. So all these features are included in Kyle. This is Kyle MDK. Slow. Okay. Let me quickly go through. I have to still demonstrate DS. This is an add-on option for FuseRTS. Basically, this is for MDK professional, like MDK license, higher end MDK license. If you take, you can get access to this FuseRTS, but this is again add-on option. So what is this FuseRTS? This FUSA is functional safety real-time system. Okay, so what does this functional safety real-time system means? As I told in the previous slide, ARM compiler is safety certified. So when I tell ARM compiler is safety certified, your compiler is been certified by TUV SUD, but your ARM libraries are not certified by TUV SUD. So in this FuseRTS, some of the libraries which ARM feels can be useful and targeted for automotive, industrial, medical, railway. These libraries, around 200 libraries are being TUV SUD certified. And you also get the RTOS. RTOS is an RTOS from ARM itself. And here the RTOS kernel is also been certified. So basically this solution anyone can go if you are developing any safety critical application with an RTOS, and if you're planning to use the RTOS as Kyle RTX RTOS. Okay, this was a FuseRTS library. So at present it supports only these Cortex processors, Cortex M0, M0 Plus, M3, M4, M7. ARM has the plans of extending this to M23, M33, M35P, but no plans for extending this to Cortex-A. Okay, so if at all you're planning to develop any safety critical code for your application which goes to any of these domains, automotive, industrial, medical, railway, then you can thinking of going to FuseRTS. Okay. So now coming to ARM Development Studio. So this is the ARM Development Studio. These are the components of the ARM Development Studio. One advantage with ARM Development Studio is if at all you purchase ARM Development Studio, you will get this Kyle MDK license free. Okay. So here you can see ARM Development Studio. It has Eclipse-based IDE. It comes with the ARM debugger, stream performance analyzer. What is streamline performance analyzer? We will talk about in the next slides. MDK we spoke about in the previous slide. Both the IDs you can see compiler is common. C or C++ compiler. So you can develop your code in both C as well as C++. Okay. Then we have software packs. For MDK, whatever software packs I showed, same software packs are being applicable even in Development Studio. Sorry. Then we have simulation models. Simulation models, we do have it in Kyle as well. But in Kyle, we have only fixed virtual prototypes. FEPs means the simulation models are fixed. You cannot customize them. You cannot tweak them as per your hardware. You have to just test the program on the hardware and see how it is on that simulation model and see how it is working. But ARM something called as has ARM cycle models, ARM fast models. These are something it's customizable. Customers can develop their own simulation model based on their target hardware requirement. This is not there in your Kyle. Kyle only supports this. So you can see whichever is common, it shows under both the boxes. So simulation models, FEP is common in both, so that is written. But whereas cycle models, fast models is part of DS only. Dstream doesn't work with DS, Kyle, excuse me. But U-Link, Dstream, all this works with your DS, but Dstream doesn't work with Kyle. But all the U-Link debugger, JTAG debuggers work with Kyle. So coming to the various editions of ARM Development Studio, we have bronze, silver, gold. We also have platinum, basically. So this is actually on the developer.arm.com. Here I have just captured the processor cores, suppose M23, M33, 35P, like ARM V6, V7, V8. In V8, we have A53, we have A35, we have A72, A55. So all those processor list, you can get it by clicking on this hyperlink. But this just, I captured this to show we have various editions, and in all the editions, you'll get Kyle license free. With a bronze is a lower end edition, basically. And one thing to tell you is, wherever you say have full circle, so full circle indicates that particular license will help you. It has support for the compiler as well as debugger. Wherever you see blank circle means with that license, you can only debug the code on that specific processor course, but no compiler is provided. Okay. So with the bronze is a entry level license, which supports all Cortex M processors. So basically, if you are developing a software for any Cortex M processor, then you can go for bronze. And you want to debug your code on any higher end processors like Cortex R or Cortex A. ARM V8 also here. ARM 8 supposed to be selected processor cores, which is Cortex A53, which is a popular 64-bit processor core. Okay, silver is the next edition of bronze. So here we have compiler support for even Cortex A and R, but again selected processor. So what are those processors? If you want to see, click this list. Whereas gold is a higher end edition of DS, which supports compilation and debugging for all ARM processors. So with silver and gold, you get the higher end edition of professionalized Kyle license, which is professional edition. So with the help of gold and professional editions, you'll get access to the ARM certified compiler versions of ARM, and you'll also get access to the ARM compiler qualification kit. And this is the streamline analyzer. So what is streamline analyzer? It's basically to check the performance of your application, to profile how your code is executing on your hardware, how the processor is performing. It's not only gives you the information about your application, it also gives you the information on how the processor is performing. Suppose if you want to profile it for any higher end processor core, which uses the cache or branch, how many cache fills happen, miss happen, and how many pipeline refilled happen. So basically to see the performance even of even the processor core also, you can check it out with this streamline analyzer. So you can profile your applications based on Linux, Android, or even bare metal systems. Means not all the hardware require OS, right? So they're called bare metal. So for such things also, you can use this streamline analyzer. So to use the streamline analyzer, you don't require any hardware debugger. You just require a hardware board which is running your application, even if it is a bare metal. If it is a Linux, then you should Linux kernel should have a getter daemon, some code running in the processor hardware, so that it can capture the profiling data and give it to the stream analyzer. I mean this IDE feature utility. So bare metal system also, there will be some sort of daemon running on the hardware which will capture this information. So no JTAG debugger is absolutely required. It's not at all required to do this performance optimization or system optimization. Okay, so last two slides. I was supposed to complete at 3:45. I'm overshooting. Sorry for it. This particular slide is basically to tell you ARM keeps doing the benchmarking of their compiler with the open source compiler, which is a GNU compiler. And here they're doing with the Linaro GCC. ARM invests even highly in the getting the Linaro GCC popular. But still, here this particular slide is basically to tell, compared to GCC, how commercial compiler like ARM compiler can do more wonders. So here first you can see this particular benchmarking is done on the workload in an automotive or industrial workload running on a Cortex A53. So you can see the 21% faster time execution in ARM compiler when you're generating the code with ARM compiler 6.6. Similarly, for consumer workloads for Cortex A53, with 32% more time in execution, means it executes faster in comparison to the code generated by the Linaro. And here minus is the optimized code. So this is tested on Cortex M4. So it reduces, it generates 33% less code in comparison to GNU ARM embedded compiler. So this particular slide is basically for the benchmarking and to show where ARM compiler stands. So ARM compiler for safety applications. Here I was talking about in functional safety also, it's the same thing, repetition. So ARM compiler is TUSUD certified to develop the code. In this particular compiler has been certified for all SILs. SILs is higher SILs, safety integrity levels, like automotive has up to a SIL D. So the highest safety integrity level, it has been tested. Your ARM compiler has been tested for automotive application and it is been certified. Similarly for railway we have for industrial, we have for medical as well. So what's the advantage of using this is you can, as I already told in the previous slides, you can use this ARM certified compiler and develop your product. Okay, thereby you need not worry or bother about getting your software or toolchain qualification done. It's already done by the compiler and we can target only on your main software code. And even at the time of product certification in the documentary, what you give support, I mean you submit to the certification companies. If you tell you have developed the code with ARM safety compiler, your product certification will be faster. Okay, so this particular ARM certified compiler can be accessed from ARM DS Gold or Kyle MDK Professional, or you can also buy it in the standalone version where you want to run the compiler using a make file or kind of from the command line. You don't want to use with IDEs, then you can go for the standalone version. Okay, so that is the end of my presentation. So any questions, please put it on the chat window. Let me quickly go through the IDE. So hope the team is able to see my IDE because I've shared the entire screen. I have not shared any specific windows. Okay, so this is a development studio IDE based on Eclipse IDE. We can see Eclipse only, but it is highly simplified and only specific tools which are required for your software development or application development is kept as active. So this is a project explorer. So first we will start. You can either start with a file new project. Okay. Or if you have a sub project which is developed in Kyle and you want to test it on DS, you can import it from Kyle. Import your Microvision project. This is your Kyle project. or you want to get started with the sample projects provided by the ARM as part of ARM Development Studio installation, you can go for examples in programming libraries. So in examples of programming libraries, you have the sample project for all Cortex ARM, V7 and V8 architecture, and even some RTOS application, Linux applications. All some sample projects have been provided by ARM. I can show you quickly. So these are all the examples you can see. Bare metal boards examples, bare metal board examples, ARM V7, V8, CMC SATOS, core site access library, DTSL is for tracing, Linux applications, streamline sample projects, RTOS 2 sample projects. So all those you can see. And bare metal boards is basically all the popular development boards from various silicon vendors that given the example projects. Okay. So now for this demonstration, I'll be doing so you have here CMSIS pack manager perspective. So if I click that, so if someone who has worked on Kyle IDE, they'll be able to correlate this. There, when you start the Kyle IDE, pack install is the first which gets opened automatically until you disable that. See here, whatever the software packs I have installed, I can see all those. So now I'll be showing it on Cortex M Core. So I'm selecting here M3 and you can see the pack for that is already updated. Okay, up to date. So when I click M3, there are some examples which are given in this CMSIS pack for ARM. So I'll import this. I'll be showing this RTOS application with ARM compiler 6. Okay, I'm importing that to ARM DS. Okay, then I'll switch to here Development Studio perspective, and this is now imported. So here you can see properties of that particular project. All the tool settings, it can be compiler, assembler, linker, all the settings you can change, target, if you want you can change all those things. Any tool specific settings you can do that here, optimizations, all those information you can do. Image layout is basically we have to tell to the linker where it has to locate the code, means what is the starting address of the code and what is the starting address of the RAM. And here we directly take it from the sample project, which is an SCT file. I'll open and show it to you. So you have RTE device, ARM CM3, MC6. So here is your scatter file. So scatter file is called a scatter loader file or linker descriptor file. Or if you want to collate this to your JVM compiler, it is the .ld file, linker description file. So here you have to specify what is the starting address for ROM and starting address for RAM. If you want to specify stack and heap, all the information it is given in this scatter file. And now if you build the project, first let me clean the project. Build the project. So just import the project from CMSIS pack installer and build the project. That's it. This is a sample project given by ARM as part of CMSIS pack and it builds fine without any errors. It's now building. Okay, so it's took 48 seconds to build my project code. And it shows what's the code size used, read write size, everything. And it also shows the map file where my functions are located, variables are located, all those information. Because it's the same ARM compiler which comes part of Kyle, and Kyle also, when you build the project, it gives the similar way. Okay, so now that is developed, now we have to test this program in the simulation mode. So for that, I have here debug control. So I click new debug connection. I'll select model connection. Okay, so hardware connection, I'll use it if I have my hardware. So thinking I don't have hardware, I'll use the model connection. Next, so I have to give the name here. I'll give test model. Then I have to associate a project for this particular model. What is the software, which project I'll be testing on this model. I'll click this. Next, and here I have to select my Cortex M3. These are the FVPs, fixed virtual platform. So I'll go to this M3. So this FVP is a fixed virtual platform given for MPS2. MPS2 is a hardware from ARM, which is microcontroller prototyping system, just for the information of the team. Basically, if you want to prototype all the Cortex M cores on your hardware, you can go with MPS2. You have a master FPGA and the slave FPGA. The required soft IP cores of all the Cortex M are provided in the master FPGA, and you can easily program the slave FPGA and test your program. Both the boards work with Development Studio as well as with the Kyle, but you need a JTAG debugger. So select this and give finish. Okay, this is how it opens. Test model, bare metal debug, because okay, and debug Cortex M3. If you want to configure any trace options, then you can use this trace option. Cortex M3 has a trace option, at least on chip trace. Files, here I have to specify the workspace file, which is the AXF file, because if I want to debug my program, I need to load the source level debug information file. Usually in case of GNU, it will be .elf file, and in ARM it is .axf file. Okay. Then in the debugger, select as debug from main, because this particular file has a main function, RTOS application. Then OS awareness. OS awareness, here we are using Kyle RTX RTOS. So Kyle CMC RTOS. Okay. Information about this, you can find it out here. So apply and then debug. So when I click debug, this is the FEP it opens. As I told, this particular fixed virtual platform is already been developed for MPS2, and MPS2 has LEDs like that. The same thing is simulated here in the virtual platform. Okay. Put this down. Now we can see a PC is starting at the main function. So this is your green color is a main function. I can do single step. So it goes to as and do we execute here. It also shows which are the statements it executes in the command window. Okay. So now what we can do is you can go to functions tab, or if you directly know the function, suppose phase A, I want to put a breakpoint. I'll put a breakpoint, toggle breakpoint. Okay, now I'll run the program. This is the run option. Continue. It stops at the phase A. These are phase A, phase B, phase C, phase D. These are nothing but the RTOS. It just toggles one specific LED on or off. That is what this particular program does. But this program does give you an insight of how Kyle RTX RTOS, CMC's RTX RTOS works. Okay, so now I can show display threads here, and we can see here all active threads. Active threads is because now PC is at phase A. So this is what is showing that thread is stopped at phase A. Then all threads, they are all the tasks which have been defined in my application. Phase A is a task, app is a task, phase B, phase C, phase D, Clock is also task, and you have idle thread, means when none of the tasks are executing. Instead of wasting the time, a processor gets into the idle thread. And here, if you want to consume your power of your overall application, you can put the processor to the sleep mode. And because the task switching happen from one task to another once the system timer overflows. So that is nothing but an interrupt. It generates an interrupt. So once the processor gets a system timer interrupt, it wakes up from the sleep mode. Thereby, the power consumption of your application can be reduced. Just giving an example. So any code you want the processor to run in idle thread, you can put it. It's an editable function. You can do that. Okay. And here OS data you can see. OS data is here. If you don't see, you can click any window you want, click add, and you go to other, and whatever window you want, you can find it out. Like I'll close the OS data now, and I'll show you. Okay. So here you have to specify, say which kernel component you want to see. Suppose I want to see the status of all the tasks. It shows me here. RTOS we tell it's a real-time operating system. It's a multitasking, but in reality, only one task will be running. Now phase A is running because processor has stopped at phase A. All others are in ready state. So other threads are waiting for a message or a delay. So like this, you can see all the status of the task. You can see which particular task is executing. You can do single step. You have register view. You have disassembly view. Registers you can see here. 4 registers you can see. System registers you can see. System means if any system interrupt you want to see, or NVIC is nested vector interrupt controller. This is part of the Cortex M3 core. It's inside the core itself. You want to see any NVIC configuration registers, all those you can see that in the registers. And any variables used in your application, globals have not used anything, variables have used inside the function, it will show automatically here. Like a normal debugger, it shows all the information. So this is about a DS IDE, a Development Studio IDE. This is to help you just get started and show you how the DS IDE look and feel, how to create project and test your program in simulation model. Surely I'll be coming with the next webinars where I'll be trying to connect the actual hardware and show you the performance of how DS and the JTAG debugger in combination can help you in debugging your code or generating an optimized code. So I'll be coming up with the future webinar topics. Okay, so now it's time to take the questions. Okay, first question. Ramya Krishna Koduri. Okay. A57 versus A72. Rama Krishna. See, A57 and A72 both are that 64-bit processor cores. But if you want to really get into the details, differences of it, you have to visit developeram.com to find out these architectural differences. I may not be able to answer you here. Sorry. Building the project from scratch. Radhika, we are recording this session. Once the recording link is up, our backend team will share you the details and video link, and you can visit that. And if you have still any doubt, you can reach out to me. I'll give my phone number and email ID. Maybe in the presentation or somewhere I'll write. Okay. How to select multi-core? Multi-core. See, multi-core depends on, because I just showed you on Cortex M3 core. Like if you select processor core, like if you go for, let me show you, Rakesh. Let me disconnect this target. Okay, file, import. I'll go to this and I'll go to examples. Environmental. Should show here. don't see there. Silence. Okay. So if depending on what processor you select, suppose here Xilinx Zinc I select. Zinc has two processor cores, Cortex A, two Cortex A9 cores, Core 0 and Core 1. There at the time of debugging, you have to specify on which processor core that particular application will be running, Core 0 or Core 1. See this project. Debug configuration I have done here. Na? So suppose if I go for new configuration, because the project is Cortex M3 thing. Okay, here, suppose if I select Xilinx and I use the cascaded one. So this has two cores. Okay, Cortex A9, two Cortex A9 cores, 0 and 1. Usually we select SMP when you're loading the Linux application onto the processor or a Linux kernel to debug how it is executing. But when you're bare metal debugging, you have to specify specifically on which particular processor core you're debugging the code. So based on the processor you select, like if you go for Freescale Hybrid series, it has Cortex A5 and M4 combination. Like if I go for this, so this one, this is also A5. Like yeah, this one, Cortex A5 and M4 combination. This is hybrid series. So multi-core debugging option comes based on the what processor device you have selected for your project. Based on that, which specific processor core you want to download the code and test or debug the code. Okay. Debugging a ARMv8 target. Ramakrishna, we don't have ARMv8 target to show you the demonstration. As I told in the next upcoming webinars, I can show you on ARM V7 target only, which is Cortex A. That same Xilinx what I showed, we have an AMLED board which has Xilinx Zinc FPGA. I'll show you the debugging on that target. Or if you want for ARM V8, I'm not sure if FEPs are there provided. You can what I suggest is you can download the development studio, which is 30 days. Okay, I forgot to tell that. If anyone is interested to evaluate ARM development studio, we can download from developerarm.com. You'll get a 30 days gold license and you can evaluate the features of the software. Geeta ji, this tool is support for ARM as well as Cortex project. It is free tools. No. As I told, during the presentation, this is a single universal tool suite which supports all ARM processors from the lower end ARM7, ARM9 to higher end Cortex A, Cortex R, Cortex M, both 32-bit and 64-bit processor cores. I mean V7 core, V7 versions as well as V8 versions of the processor cores. It is not free. You have to pay for the software license. Yeah, support to RTOS I showed you. Here. So you see, these are the RTOS supported. We have free RTOS, Kyle CMC RTOS, Nucleus RTOS from Mentor, RTXC RTOS from Quadros, ThreadX again, so WindRiver, Emboss is from Segar Embedded OS, Mucos is a Micrium OS. So these are all the third-party RTOSs which are supported in ARMDS, which you can do the debugging, kernel level debugging. Very good means you have to, the credit goes to ARM. Can we use ARM Development Studio with System C simulations too? System C. What is System C simulations? Ish, can you reframe your question? I'm not able to understand. System C. See, ARM development tools can be used with Jenkins for continuous integration, or you can also use a Python script for doing the automated debugging for a JTAG debugger. Yes, just now I showed you, na? Silent Zinc Ultrascale RF SOC ZCU216. Wow, I have to check that. Just trying to show. Silence. Ultrascale is only this one. NP-SOC cascaded. RF SOC ZCU216. One thing I can tell you, Palaniswamy, here is if this processor has ARM core, then it should be supported. Even if it is not listed like Xilinx, you can also select only ARM processor core, like how I set it for ATOS application Cortex M3. Like that, you can select the specific processor core and develop your project. How to add a platform with certain ARM core type to the DStream to debug the set platform. Ramakrishna, you need not add any platform. As soon as the DStream or any Ulink JTAG debugger you connect to your hardware through DS, it automatically detects all the JTAG enabled devices and it will automatically connect to the processor core that you have selected. Even if you want to still add a platform, like you want to add a development board or something, you can use platform configuration editor, PCE. Yeah, for adding the peripherals in simulation, as I told Vinay, what I demonstrated was a FVP, fixed virtual platform, which is actually this is simulation model is developed for MPS2 board. So you could see all that LEDs display and all. But if you want to add peripherals to the simulation models, then you have to use the ARM simulation models or ARM fast models. Here you can develop your own simulation models. TFT display simulation. I don't have any sample project for that. Rameshwar Kakade. What is the cost? Okay. Rameshwar Kakade, please send mail to my mail ID. I'll share the cost details with you. I'll put the email ID, which debugger tools it support. Debuggers, okay. I'll show you here. Suppose if I go for 53, these are all the, okay. DStream Ulink Pro, Ulink Pro D. This is for all your Cortex A series. Okay, but if you go for Cortex M series, like if you go for Cortex M, you have all this DStream, HSSTP. This is a serial high-speed serial trace probe. We have ST, we have PT, we have Ulink Pro, all the versions of Ulink. Ulink Pro, all the versions. It has CMSIS DAP also. CMSIS DAP is, as I told, CMSIS has various editions. So CMSIS DAP is debug access port. So this is for debugging your application. So this feature usually it will be part of debugger or it will be present on the hardware. So these are the debuggers for Cortex M and for Cortex A. We have only three. DStream, Ulink Pro, Ulink Pro D. There is no third-party debuggers. Can we simulate code running from a QSPF flash? configure cache size, and evaluate the performance. Yes, everything can be done, as I told, but you have to develop your own simulation models for that.